Technology has always been the great marker of time. The printing press, the internal combustion engine, the Industrial Revolution. That word, revolution, is anything but hyperbole. For every society-shifting advancement, there's a before time and an after. These innovations define our history. Their creators forever remembered and forever revered. But we're not here to make our mark on history. We're here to make our mark on the future. To make cities safer and run as efficiently as the human body. Autonomously sensing the world around us so human minds can be free to do what they do best. Create even better ways to make the world a better place. But this isn't a fanciful dream. We have the technology now. Today, we can automatically detect an accident, alert emergency response, and reroute traffic in the blink of an eye. We can connect physical security and video surveillance throughout a city to detect threats and respond immediately. Cars can sense pedestrians and obstacles, brake on their own, and communicate with the vehicles behind them to do the same. The smart city that was once impossible has arrived. This revolution is waiting for no one. It's going full speed into the future. FLIR, the future of brilliant cities.
Yeah, welcome to this webinar. How does artificial intelligence enhance traffic signal control and traffic safety? My name is Benjamin Schirek, and I'm guiding you today to this webinar. A few words to me. So I'm business developing manager at FLIR and mainly focusing on smart cities. FLIR is a US company. We are active in 173 countries around the world, around 4,200 employees worldwide, and we are focusing in different sections. One of them is ITS, Intelligent Transportation Systems. So FLIR's main business is thermal sensors. But as you can see, we have 95% is our thermal and 41% is our non-thermal business. So I would say thermal is still the biggest part, but we also have a lot of other solutions. So before we start with explaining the future of AI and what AI can bring, I want to give you an introduction into one of the projects which we are currently doing in Hamburg. The Smart City Revolution was a webinar that we did earlier this year, and maybe some of you already heard about this webinar. So what have we done in Hamburg? So we did different projects. One of them called BD Move. This is a bus awareness system, which actually warns the bus driver if a bike is next to them. We have the bike counting network. This is around 100 bike detection systems around the city, and gives them information how many bicycles are traveling through the city. We have the tunnel fire detection system in the Kronstieg tunnel. This is the airport tunnel in Hamburg. And we have the biggest one, this is the traffic counting management system, which is over 2,000 cameras which are counting and classification, do counting and classification across the city. So how does that work? So in general, we are always installed somewhere on a pole. This is mainly a traffic light pole where our camera is installed. From there, we have a BPL connection towards the controller. To explain BPL, for those who never heard about BPL, BPL stands for Broadband over Power Line Communication, and it's a two-wire communication between the camera and a device. The advantage of it is that you only need a standard signal cable, so no shield cable, a twisted cable. It can be the standard power cable. And we are transferring the TCP/IP connection, so the network connection, over that 2 wires. It can be daisy chained up to 7 devices in a row, and the interface card has 16 dry outputs plus 4 air outputs and an Ethernet connection to the outside world. This is what we do here in Hamburg as well. We are sending all the information from the camera towards this device, and from there we are sending it towards the cloud. In this case, it's the FLIR Acyclica cloud, which is gathering all the data. So in theory, it works like that. Every minute, the interval of the traffic situation is being transferred toward the cloud and stored there. From there, we are using the front end and the API to other Hamburg authorities and holdings in order to access the data. But secondly, we are delivering all the data into the Urban Data Platform of Hamburg. The Open Data Platform is a hub where any kind of smart city data, so parking data, traffic data, roadwork data, everything that comes along the city is actually being stored and can be accessed either again from Hamburg authorities or also from third party. So if you want to program your own app, you can actually ask access to this data platform, and then you can retrieve all this kind of data and program your own app, for example. So the first project, V2X and bike detection. This is one of the things where we first time used AI. What we actually did is we put detection into real life coordinates. So a bicycle that is driving next to the bus is being detected, and this information is sent by a roadside unit as a CAM message towards the bus. So in the public transport bus, there is an onboard unit, and these pixels, so the real world GPS coordinates, longitude and latitude, is actually sent, and the bus is actually know, okay, there is a bike next to me. So we are doing the classification, and we are sending this information out. And this is, we are doing this in the following way. We have the camera, and the camera gets a GPS coordinate, and then every pixel is turned into a GPS coordinate. So with that, we actually know exactly where the person or the bike is in the real life. And from there, the information needs to go to the bus driver. So that's something a partner has developed. We have, in fact, a little light over here. This is just one of the examples. There are existing different ideas how we can visualize it. But here it's, in fact, a light that turns from yellow into red in case there's a bicycle next to the bus. The other project is the automatic traffic counting system. So this is a network of around 2,000 cameras around the city, which is actually collecting data. We started with 3 classes, but with AI today, we are able to go up to 5 classes. And we actually were able to do this with AI. Why? I'm going to explain a bit later, or what are the advantages of AI, but we actually started here with 3 classes. So this is how it's working. You have here the thermal image. You have 2 zones, which are doing the classification. In this case, we also have a bike zone on top of it. So we do bike classes or bike counting in both directions. And then we have the traffic classes, which are doing the speed, the counting, and the class. That's also what you see on the top left, upper right, or top left part in the image. You actually can see the length and the width of the vehicle. And this is how we are doing the classification. So what we are doing here is we do traffic flow speed, occupancy measurement, at the average speed, the classification, the headway, the gap time, the integrated and individual data. So what is individual and integrated individual? So integrated is we are putting this into 1 minute together. Then we transfer that into the cloud. We will also be able to do this individually. So you're getting actually a live feed from the camera with every vehicle that is passing by with the information. It's not being used in this project, but in general, this is possible. Either a smaller project, but also where we are using AI of detecting fire. So the idea or the problem that the customer here has is that the Kronstieg tunnel is the airport tunnel, which is only around 700 meters long. The problem with the 700 meters is actually if there is a fire, the fiber optic cable on the roof, because the wind is going through the tunnel, is always cooled down. So that you're getting an alarm is already a quite big fire, and you need a lot of heat in order to generate an alarm, and it takes a long time. But this is the main entry and access towards the airport. And secondly, there's always also the runway on top of this tunnel. So for the customer, it's very important in case there is a fire that is detected very, very fast. And you actually can see an example of a fire that, of a car that went into fire in the tunnel itself. So we detected this after, I think 10 seconds was the stop vehicle, and around 13 seconds in total, we detected the fire. You can see it here in the image later that it says stop vehicle and then fire. So we have stop vehicle and fire. And you see that the tunnel is still open, so the traffic still goes through. But the good thing here was they can react very, very fast. So if they get this within a few seconds, they have the good possibility to distinguish the fire very fast. And that actually helps to reopen the tunnel as soon as possible. Because if you have a fire in the tunnel, one of the big risks you have that you have to close the tunnel for hours or even for days, because you need to refurbish things. And secondly, there's the runway on top of it. So this also can create more issues because maybe airplanes cannot land there anymore. So that's why the customer here was looking for an alternative. So why should we use FLIR for smart cities? So the first thing is the FLIR sensors, we can measure the real-time traffic and we can control it. So we can do the standard loop replacement in your city towards the controller via dry outputs. But in fact, all the information can be or the extra information can be sent into the cloud. And from there, we can do more analysis. It's extremely easy to use. We are using the BPL technology, which makes it very easy to install on your intersection. And all our products are cyber secured. The FLIR Acyclica Cloud has built-in performance measurement tools. We can do travel time from intersection to intersection by tracking MAC addresses. And we actually can help you to find and to plan your city environment. But it's not only planning, it's also development and implementation. So FLIR offers you either own tools or complete APIs, for example, to integrate the traffic data into a traffic management system. So to use this extra information, for example, travel time, to control your traffic lights. And at the end, we can monitor and evaluate the data. So it's very important. I mean, if you see today's cities, they are changing drastically. So today there is a shopping mall, tomorrow there is a big complex for apartments, or vice versa. Or suddenly a cinema becomes a different building, or you are changing your public transport. So because you're adding stations or whatever. So your city is moving constantly. And what is very important to understand how your traffic is moving constantly. Because if every change in the city, your traffic will change. So one of the big things we have today is that we are adding bicycle lanes. So we are removing a standard car lane or we are making it smaller and we are putting a bicycle lane. And we can actually show you how this is changing the traffic. So in fact, we are giving you a map with all your sensors, and by clicking on one of these sensors, we can gather you all kind of information and we can actually visualize the data. And the good thing is it's all secured. So we are putting a lot of effort in GDPR and into privacy security things. So this is a very important factor for us. So everything is secured. So all the data that we are sending goes over HTTPS SSL connection. It goes into the FLIR cloud, or it can be also on-premise solutions. And then from there, you have the front end, but also the API into third-party systems. So now talking about AI. So what is AI? So AI is artificial intelligence or deep learning. This is what we mainly hear it for. It's a little bit the buzzword that we hear in a lot of things today. But what is it? So AI is actually to learn a system based on images. It can be also sound or text, any kind of data AI can be learned. So in fact, you are showing the deep learning engine a picture and saying, this is a pedestrian. And you take another picture and say, this is a pedestrian. And you take another picture and say, this is a pedestrian. And take another one and say, this is a dog. And then you say, this is a truck and this is a car. And you need tons of these images. And the algorithms will understand how it looks like and will say, now this is a pedestrian. And this is actually how it works. So I also could explain it how you learn a child. If you show them a picture book and there's a crocodile or an elephant, you will tell your child, this is a crocodile, this is an elephant. And sooner or later, it will see a crocodile or an elephant and will say, crocodile, elephant. So this is the same how it works. So on the left side, you can see here the deep learning says truck and it says 83. So this is 83% sure that this is a truck. This is always what we are getting from AI. It gives you a value how sure it is that this is a truck. And for that, it needs to be learned. And we all know this from the internet that sometimes you have to say, I'm not a robot, and you have to click certain pictures on the question that he's asking you. And this is how actually deep learning is being trained. So what we need is actually a lot of input and a lot of pictures. And the good thing with FLIR is that we are so many years in the business and we have so many tons of recorded videos and images that we were able to make our own engines and that we could learn our deep learning algorithms in order to improve things which we cannot do with the standard detection. So how does that look? Here you actually can see deep learning running on the thermal camera. So what we do is we are putting every object into real life coordinates. And on the right-hand side, you actually can see the heading and the speed of this object. And also you can see the trajectories. So this gives us a lot of information. We actually see how the traffic is fluent in your city and where they are coming from, where they are going to. So with this kind of information, we can add a lot of different information towards your detection. So we can make like heat maps. But what more important, we can actually overcome certain problems that we have today with the standard detection. So to show you that in real life, we have a thermal camera, and then you can see here on a map, on a satellite view, your traffic. So imagine in the future, you're just putting here in the real life map your zones. You're just placing your zones. The good thing is already we can count immediately how many cars, how many trucks are standing there and where they are standing. If you just see the normal image, it's probably already very difficult to do that. But with the world tracker and the real life coordinates, we are able to do this. So traditional zones have issues, especially if it's side fire, if the positioning is not very well. So we have our virtual loop. You see here on the left side picture that the truck is actually triggering more or less almost all 4 zones. The one not, but that's normally should be also triggered because it's in there. But that is actually the problem, that if you have overlappings, that the zones are becoming active because they're actually occupied. If you would do this with deep learning and the AI world tracker and looking towards the position, the speed, and the heading, we exactly know that this truck is in this lane. So we only would trigger the presence detection zone in this lane. So it really helps on difficult situations. So where we have not the chance to install the camera overhead because we have to look side fired. Why is that important? A lot of systems today are still like Mover, Scoot, Ithaca, Autopia, SCADS. So all the adaptive control systems, traffic adaptive control systems, actually need information of counting. And they mainly need counting 60 meters away from your intersection. And that is actually the biggest problem that we have, that it's 60 meters away from the intersection where we cannot distinguish 2 cars. But with the AI world tracker, it gives us new possibilities in order to do that. So here's an example. We actually have on the right side, we have the drawing of the street. And we are drawing in every vehicle that comes in. We actually draw them into the map. And imagine now you can just place your zones over here instead of placing them over here. That gives you a complete new way of detecting vehicles, and a very, very long stretch, and very, very secured. Next to that, we also have the possibility to detect extra things. So you see here, there is a double lane. So now if someone turns over here over the double lane, I think this is the bike lane, and this is forbidden or at least a dangerous situation, we call this situational awareness. So we can tell you where these difficult or these dangerous situations appear. So I think a bit later, if you watch somewhere over here, we actually can see that one of the cars suddenly just changes the lane. I think it's this one here. Yeah, now you can see him changing. And this is something we can detect, and we can tell you how often it happens in your city, or especially on that intersection. We have 2 new products. This is the ThermiCam AI and the TrafficCam AI. The ThermiCam AI is based on a thermal sensor, and the TrafficCam AI is based on an HD sensor. So why do we have now 2 products? Well, ThermiCam, this thermal sensor, brings a lot of advantages, especially during nighttime, or if it comes down pedestrians or bicycles, they don't have any light, we can easily see them. Also during bad weather conditions, thermal just brings the better resolution. But TrafficCam AI with its HD sensor has also benefits. We get more information out of the image, for example, like a color. So what we can do with that is learning AI, especially on certain images that we cannot distinguish with ThermiCam. So imagine you have public transport buses in your city, and they are always red or green with a certain logo. They have a certain design. You actually can distinguish them from public transport and normal buses. And this is something that we can read because we can learn them. We can say, if it's this bus, based on a lot of pictures, we actually can tell your system, your public transport bus is coming, and we can draw an extra output or we count them separately, for example. And this is possible with the visual one, because for the thermal one, the bus will probably look the same as another bus. So if you need more details in the image, then we are actually able to use the TrafficCam AI. But the benefits on thermal are clear, and this is also a true success in the last years. So first of all, if it comes down to GDPR, we cannot read license plate, for example. So you get a black and white image, as you saw before here in the presentation. The image looks day and night the same. Yeah, so there's in fact not a really big difference between day and night. It's not affected by rain. I would say visual is also not that much affected by rain, but at least you can see that it's raining. And if it's heavily raining, it might be affected by rain, but rain is not the biggest problem. But for example, like fog, thermal is not affected so much by fog than a visual one. Or if it comes to that you have horizon in the image because of the position, you cannot do it in a different way. For thermal, it doesn't matter if you have any horizon in the image or if you have like sun glare in it. Or special situations like bridges. Yeah, if you're looking under a bridge and you have different light situations, this might be also very difficult for a visible sensor, and thermal is not affected so much for it. That's why we think that thermal is quite perfectly suited for AI, because what AI actually needs is a very stable image. So here we have some examples, visual and thermal. What we actually can see on the black graph is that we can distinguish all these different vehicles. And for those of you who already worked with video detection, you know, if you have this kind of picture, to do loops in like 30 meters away from here and really get good counting results is more or less impossible. With AI, we see here real benefits of getting your data better if we are running it on AI. Also on the right-hand side of the thermal, you can see that even we can count how many people are going off the highway, because you can see that they are moving a little bit to the right or they are going straight. So the resolution actually of your traffic is getting much, much higher. And this is, let's say, a real core benefit that we are seeing today with AI. But one thing that we should not forget is that AI is more or less never at its limit. So it's really getting better and better as more the system is installed, because it can learn itself on the new images that are coming in. So we are really here at a very early beginning, and we already have our experience with the first thermal things, and we are using thermal and AI, or AI in general, already for a very long time to validate stopped vehicles, to validate shadows, for example, and things like that. So we already have a very long experience. But the main problem always was in the past that the processor power was not really there to run more, because AI actually needs a lot of processor power. And this is actually what we do with the new platform that we have, the TremyCam AI and the TrafficCam AI. It comes with a complete new platform, which is actually able of running AI algorithms much more than before. So this is also why now we can see these fancy images with these rectangles around it, because we actually have the power to visualize all this and process all this. So in fact, it's a circle. So what we do is we detect your traffic with all kind of information. And it's the standard presence detection that we still do, but also all the tracking information. What is important to know here is that it's a lot of data. So at the traffic controller itself, we are splitting it into two parts. So one is the outputs, quite standard towards the controller, saying there is a car, there's no car. Maybe we transfer some counting information with it, but that's it. All the rest is going in a package towards a server. That can be in the cloud, it can be on-premise, and there all your traffic information goes in. Important to know here is that we are storing all this information in some kind of a raw format. So the data is actually there from day one until 5 or 10 years later. So we are not compromising anything or putting data together or making from 1 minute interval, 5 minute interval, and then 1 hour interval or something. It stays there as it is, which gives you a very good position that you can run analytics later on old data. So I gave that example of that car. I mean, this is actually the first picture that we can see here, that there were cars always crossing, or that the car was crossing on a forbidden zone. Maybe this is not a problem today, but maybe in a half a year or in 1 year, someone comes to the idea and says, how often does that happen? We had a couple of accidents with bicycles over there because someone was moving over there. I mean, how many times are vehicles moving over that lane? And then we could go back on the historical data and say, okay, let's check it, because we have everything. We have all the trackings of every vehicle we have available. And this is the great power, especially of cloud analytics, because in the cloud itself, it's not a big problem of storing a lot of data. This is what all the big companies are doing today. And we don't really have issues with that. And we have good possibilities here of connecting different technologies with each other. Local servers, local controller who needs direct inputs, who needs direct information, plus an AI camera who brings you tons of traffic information that you can store. And maybe you cannot use everything today, but you are ready for the future. So all the data that's collected comes to the front end, where you can run some analysis. And again, your analysis will bring changes to your traffic. So for example, you decide here, we are making one line only for bikes. And then we actually can detect, how does it change your traffic? How does it change your queue on that intersection? What is it actually doing to your traffic city? And again, all this information goes into the cloud and we can compare different things. We already have that today. We call it congestion level. Congestion level can show you actually the information of your traffic, if it's getting worse or not. Because honestly speaking, almost every city in the morning, if you're looking through a map and you say traffic overlay, everything is red. That's a normal situation. I mean, it's rush hour time. But important for you is to know where it's more worse than before, or where is it changing. So maybe because of roadworks, of an accident or whatever, and there you need to look into, and there you need to react. There's no matter of like showing you everything in red. And this is actually our idea, understanding traffic in a better way. So this is why we say the next smart city is a FLIR city. Because with FLIR, we not only have thermal sensors for traffic, we also have a lot of variety on different software stages, starting over a Chameleon ITS, over United VMS. These kind of softwares can all work together with sensors or even with different sensors. So this here is just an example of a Chameleon and United VMS presentation with a customer who's actually using our VMS and our Chameleon, which is a SCADA system for traffic, to look to all kind of traffic information, to look to cameras, of course, and to combine different things. And this is also important because a sensor that brings you a lot of data, you need to do something with that data. So there's no reason of putting the data somewhere on the cloud and don't use it anymore, or let it store on the server, but you cannot use it. And today we have the technology to bring you also the software with it, to combine different things, to give you information where traffic is changing and where you have problems. So another thing where we are using AI, not on the camera itself, but in the cloud, is on our smart vehicle search. So Smart vehicle search is actually a license plate recognition system based on the cloud. So what we do is we are using our standard cameras to detect license plates. The bad thing, of course, is the cameras are not in a very good position of detecting all license plates. But normally we have a lot of them across the city. And every camera is trying to catch license plates. So all this is sent to the FLIR cloud. It's being recognized over there, comes back to your database. And then from your database, you can do a search on vehicles on license plates. So that's another example. It has nothing to do with the TrafficCam AI, but it's just another example how we can work together with different kind of technologies and where AI also in different other technologies can be helpful to build up a smart city. So with that, I'm coming to the end of my presentation. And as always, it's a short time, it's a lot of information, but you can always reach out to me. You'll find my mobile number here, my email address, my LinkedIn account. So I'm pretty happy to answer all your questions that you have. I'm pretty happy to maybe discuss your projects that you have. And yeah, so I'm at the end, and I think now we have a Q&A. So probably there are already a lot of questions that we can answer already now. If not, then we are going to reach out to you later. But Aubrey, thank you so much for your attention. And yeah, now we open the session for the questions. Thanks.